We're still in section 2.5. Today in this video focusing on objective number 2, being able to find a linear regression equation for a data set using technology. Okay, so let's recap what we already did so far in a previous video. We took a data set. In this case, the data set represented how long it took a certain group of or certain number of students to do the wave. And we represented that data set with a linear equation. We did it by hand, just picking 2 points in the data set. Okay. Now, when we do this by hand, our equation is not always the most accurate. Okay. So there is a much more formal way, statistical approach to coming up with what's considered the true line of best fit. Okay. Now, we're not going to be able to do that by hand ourselves, the true statistical approach, because it's beyond the scope of this course, but we can have technology do it for us. Okay. So if you click to example 2, you're going to see some instructions on how you can use Desmos to find what's known as the linear regression equation, or the true line of best fit for a data set. Okay, so let's use the same data from our wave example. Okay, I want you to click the Desmos word there and open up the website. Once you're here, click Graphing Calculator. And the first thing you're going to do is insert a table in. So we're going to hit the plus sign in the top left, insert our table, and now we can type in our values from our data set. So the first point, 4 students took 1.96 seconds to do the wave. Our second point, 8 students took 4.58 seconds to do the wave. Third point, 12 students took 5.13 seconds to do the wave. Fourth point, 16 students took 5.48 seconds to do the wave. And our final point, 20 students took 5.76 seconds to do the wave. And you can see that as I was inserting those points into my table, the points are being plotted over on the graph here. So here's your scatter plot. Okay. So now let's tell Desmos to come up with this linear regression equation. It's a little formula that you have to type in. Okay. So we're going to type in y followed by a 1. And then we're going to hit this little symbol. If you take Spanish, that's referred to as a tilde, right? Then you're going to type in mx1 plus b. Okay. Now the reason I used y1 and x1 is because if you look in my table, the values are being labeled in terms of x sub 1 and y sub 1. Okay. Now notice that once I typed that little formula in, it started spitting out some numbers for me. It gave me an r squared value, which we're not going to pay attention to right now. It gave me an r value. We'll talk about that here in a moment. And then right now, what I want to focus on are the parameters of m and b. Okay, m is the slope of your linear regression equation, and b is the y-intercept of your linear regression equation. So let's go back into our notes, and we're gonna copy those down. Okay, so y equals 0.2125x plus 2.032 is our true linear regression equation. Notice that's a little bit different than the one that we calculated by hand. Our slope and our y-intercept are a little bit different values from what Desmos is giving us. Okay. All right, now let's use the equation to make the same prediction that we did yesterday, how long it's going to take 100 students to do the wave. All right, a couple ways you can do this in Desmos. So notice that the line is actually graphed now, okay? So one thing I could do is I could go all the way out to when x is 100 and find the line, put my finger on the line, and you can see it's a little touchy, but right there when x is 100, y is 23.282. So that's one way you could do it. Or this is a calculator as well, so we could actually insert 100 into our equation for x and solve. So 0.2125 times 100 plus 2.032 gives us that same y value, 23.282. Okay, so let's put that into our notes. All right, so once again, notice that is a very different value than the answer we got when we did this by hand. Our Desmos value is much more accurate. All right, now moving forward, one other thing I want to draw your attention to is the R value that was given by Desmos when we put that little formula in. Okay, so if we go back here, notice under statistics, it's giving you an R squared value and an R value. We're not going to pay attention to R squared. We're only focusing on R. In this case, it's 0.8781. Okay. All right, now let me explain what R represents. This is referred to as the correlation coefficient. And basically, it is a number that tells you how strong of a linear relationship you have between the two variables in your data set. Okay, so here are the rules of a correlation coefficient, this R value. It has to be a number between -1 and +1. Okay, the closer the R value is to +1, the stronger the positive linear relationship between your two variables. So in our case, R is 0.8781. That's not too far off from a value of 1. So that's telling me I've got a fairly strong positive correlation. Okay. The closer R is to -1, the stronger the negative linear relationship. And then the closer R gets to 0, the weaker the linear relationship. Okay, so let me illustrate this concept a little bit further using GeoGebra. All right, so here you see we have a scatter plot of points. The line of best fit has been calculated. That's the equation is up in the top left, and then the correlation coefficient for R is shown as well. So right now R is 0.4935. That's not really close to 1 or to -1. So right now we don't have a very strong positive or negative linear correlation. Okay, I'm going to move the points of my data set around, and you'll see that that's going to adjust both the equation and the R value. Okay, I'm going to try to pull these points a little closer together. Okay, and you can see that as I'm doing that, these R values are getting closer and closer to 1. Okay, the only way I'd get to exactly 1 is if the points lined up all exactly to form a straight line. Now, the further I move these points away from one another, see how my R value is getting really close to 0? That tells me I've got a really weak linear correlation. Okay. Let's say I move the points to where I have a negative trend. Okay. You see, the closer I line these up to forming a line with a negative slope, the closer that R value is going to get to a -1. All right, so hopefully there's a good visualization of how the R value relates to the points of your data set. Okay. All right, so at this point, it is your turn to practice. If you click on the practice tab there, you'll see you've got a second data set for you to input into Desmos and then calculate the regression equation, make a prediction using it, and also interpreting the R value associated with it. So pause the video, um, work through that example yourself, and then come back and check your work with mine.